Hello, and welcome to this 100ZR collaborative demonstration by EXFO, Juniper Networks, and Precision Optical Technologies. We've built a small-scale demo to showcase a real-life example for testing and deploying 100ZR optics for network operators. We've got a couple of EXFO test devices to generate traffic, 100ZR transceivers, an 8-channel mux-demux, a spool of 75 kilometers of single-mode fiber, and a Juniper host platform. Central to this system design are footprint-optimized 100ZR optics that fit within the QSFP28 form factor. We're featuring a total of 4 100ZR pluggable optics, 2 from Juniper and 2 from Precision Optical Technologies.
Our test platforms include 2 of the EXFO FTBX 88260 portable units, who I have in front of me, each with a single 100 gig port where we have one of the transceivers of Juniper and Precision Optics plugged in respectively, sending traffic bidirectionally. The EXFO FTB88260 module is the most compact tester on the market. It does support 100 gig ZR QSFP28 transceiver validation and provides a variety of statistics and values like optical signal to noise ratio, CDPMD, as well as the capacity to configure the characteristics of the client and the transmission power.
These optics are intended for long-reach applications, either in unamplified or amplified networks, with reaches up to 300 kilometers when paired with an optical line system. In our demo here, these transceivers are being connected to an 8-channel mux with 100 gigahertz spacing, and we're using ITU channels 29 and 31 on each side, being run over 75 kilometers of fiber, the mux in another 8-channel mux that connects to the Juniper ACX router hosting the peer-side 100 gig ZR optics.
The success of IP-over-DWDM requires systems designed mindfully to support the power and thermal management requirements of pluggable coherent optics. The Juniper ACX 7024, part of Juniper's ACX 7000 Cloud Metro portfolio, is an access and aggregation router that delivers 24 multi-rate low-speed ports for downstream connectivity and 4 100 gig ports with uncompromising support for 100 gig ZR coherent uplinks. Thanks to Juniper's focus on standards, the Junos operating system leverages CMIS host-to-module interface specifications to both configure and monitor key optical parameters on coherent DWDM pluggables. Additionally, with Juniper's support for open APIs, operators can extract relevant optical information from the router and consume them using open source visualization tools like Grafana.
One of the key advantages of 100 gig ZR optics with the CMIS is advanced monitoring parameters such as CD and OSNR, and also the possibility to natively tune the frequency to desired channels via the host, as we're going to do in the EXFO and Juniper hosts as we tune to the ITU channels 33 and 35.
For host platforms that do not support CMIS yet or have legacy software that won't be upgraded, we're also going to show the tuning capability of both optics for SFF managed optics. For these 100ZR transceivers, external tuning will need to be performed using a host like the Precision TN100 QSDD management module.
After tuning both transceivers to a different channel, we will change the physical mux connections to channel 33 and 35 on both sides, causing the links to go up again and traffic to start flowing bidirectionally on both EXFO and Juniper hosts. The availability of QSFP28 100 gig ZR solutions builds on the success of 400 gig ZR, extending the compelling TCO benefits of IP-over-DWDM to new metro, data center, and enterprise use cases. With real-world alignment of low power and small form factor coherent pluggables, purpose-built routers and test systems, and robust industry standardization, the time is now for deploying a converged optical routing architecture.